Hello, everyone. Welcome to today's webinar. We're going to give it just about a minute or so. We still have a bunch of people trickling in, so we can see the attendee list here. So just hang tight, and we will get started in about 1 minute. Thanks. All right, folks, we're going to go ahead and get started here. Well, hello, good afternoon, and welcome to today's event. This webinar is entitled Next Gen 911, Using Aerial Imagery to Improve Data Accuracy. My name is Joe Oddie. I am the Director of Partner Strategies here at EagleView, or Pictometry, as many of you may know us. And we're here to talk a little bit about the data. As many of you are undoubtedly aware, there is a nationwide initiative to update the data used in 911 centers to be Next Gen 911 compliant. Each of you are more than likely at a different point along that road. So today's webinar is meant to explain how high-resolution, accurate aerial imagery can be a valuable tool in these efforts, and how our partner company, Imagery, can help you get there. So before we get started here, we have a full agenda. We want to make sure that we leave time for questions, but I got to go over a couple of housekeeping items to ensure a positive experience for everyone. So first thing you may notice is everything on your screen is customizable, meaning that you can reposition and resize all of the boxes to your liking. So feel free to go ahead and play around with the interface and try it out and see what works best for you. If you do have any questions, please submit them through the box titled Ask a Question, and we'll work to address all the questions at the end of the call. There are several resources available in the box titled Related Content, including links to content that we'll be referencing throughout today's call. Feel free to explore those as well. And finally, there are survey questions we'd like your help answering, so feel free to respond to those at any time during the event. Okay, so let's go ahead and get into it. As I said, my name is Joe. I'm the Director of Partner Strategies here at EagleView. We're doing this webinar in conjunction with Imagery. Imagery is from the state of Hawaii, and they are a trusted and responsive information and technology data service provider, specializing in 911 GIS and 911 database provisioning for 911 dispatch and response PSAP systems and equipment. Imagery helps manage complex database requirements and standardization mandates for local 911 and emergency service. Imagery's expertise help align with, optimize, and ensure accuracy of local emergency services designed for 911 dispatch and response needs. So you're going to be hearing a lot from them on today's call. So let's just go over the presenters for today. Along with myself, we have Ruth Zipfel, who is our district sales manager from EagleView, and she's out on the west coast of the states. We have Katja Kriva-Rijka. She's the GIS manager with Imagery. And we also have Tommy Takeshita, who is the operations manager with Imagery. So let's go ahead and this is our agenda. So we're going to talk a little bit. I'm going to talk for just a brief moment at the very beginning about who EagleView is. And then we're going to get into, Ruth is going to talk a little bit about Hawaii's 911 program and definitions. And then the folks from Imagery will go over the next couple of bullets that you see there on the screen. And we'll learn a little bit about how our imagery can be a valuable tool to help you folks get your data to be Next Gen 911 compliant. So a little bit about EagleView. For those of you who don't know, again, we're also known as Pictometry. We started that company called Pictometry back in the year 2000 in Rochester, New York. And we really pioneered the idea of high-resolution aerial oblique photography. And we are the best in the business at this. We have natural color balancing and no atmospherics in our imagery. We capture this all from aircraft, and it's done at a 45-degree angle. And we also capture the top-down perspective as well. When it comes to those side angles, or what we call obliques, we capture not only this image that you're seeing like from this perspective, but all 4 cardinal directions, so that you can rotate a structure around and see it from all 4 directions to really understand what's going on out there in the field. We customize our flights with our customers, so we don't just fly when we want to. We work with our customers and they dictate how often we fly, so we could fly multiple times a year, once a year, or once every 2 or 3 years. We customize the time of year. Some people prefer flights in the spring, some in the fall, some in the summer. And the resolutions as well. Some people like real high resolution in the urban areas and maybe need a little less out in the rural areas. So we really work with our customers to define the project that they need. We have over 300 international and domestic patents, everything from the camera lenses to the mounting rigs to the processing stacks of our software. Pretty much from A to Z, everything is done by us, and we vigorously defend these patents in the market. As I mentioned, all of our imagery capture is done by aircraft. We have over 120 aircraft right now in our fleet, and we span throughout the US and Canada, including Hawaii. And we try to fly for the most part with no leaves on the trees and no snow on the ground. So that means that this time of year in December, our planes are usually in the south. So we're in Texas and Florida and Southern California. And then in the spring, as the snow starts to melt and the leaves start to bud, we try to follow that line so that we're capturing with no leaves on the trees to get the maximum penetration to the ground. So that allows our customers to see as much as they can see. Oops. We spend over 60,000 hours in the air every year. So with all of our pilots flying every single day for all of our customers, which numbers we're around 2,000 customers at this point. We're flying every single day, capturing a tremendous amount of imagery. And that equates to about 1.6 billion images in our database, which is pretty incredible. It is all cloud-based. We still do deliver it physically, but most of our users are using it through the cloud, where you can access it through APIs, through our desktop applications, through browsers, through mobile apps. We have a lot of different ways to access this great imagery. And because we have recurring customers, you have a lot of historical imagery to look back on. So if a disaster were to happen or an emergency where you needed to see what did it look like before a storm and after a storm, we have all that historical imagery for you to look back on. As I mentioned, we started in Rochester, New York in the year 2000 and had a smattering of customers in the Northeast. We had one in Florida and one in California. And then if we fast forward to this year, you can see that we've grown quite a bit. And we have offices now, and again, in Rochester and also in Bellevue, which is outside of Seattle. And we have a tremendous amount of coverage. We're over about 95% of the populated areas of the United States. And so there's a good chance that we have imagery of your county out there. And we continue to fly on average every 2 years. So just a real quick, before we hand it over to the other folks, just a real quick heads up that one of the things that may come relevant with this webinar is the fact that we can now capture 1-inch resolution imagery. So for a long time, 3-inch resolution was kind of the gold standard. And that's what a lot of our customers currently purchase from us. But we now have the ability to capture sub-inch or 1-inch imagery from our aircrafts. So it just gives you a tremendous amount of detail that can really help you in your addressing as you're trying to update your GIS data to be as accurate as possible. Our orthos are extremely accurate to the Earth, and combine that with this high resolution imagery. It is such a valuable tool to help you in this effort. So here's just a couple of images here just to kind of show you the level of imagery that we're capable of producing from our aircraft. Again, this is not a drone. This is from thousands of feet in the air from our aircraft. So you can tell the tremendous amount of detail that you can get from this image. Again, just like before, you can rotate it. You can see all 4 cardinal directions. And then you can also see the top-down perspective, the orthos, which is important for your GIS work that you need to do for addressing. You can tell what streets, with this level of resolution, you can read street signs. You can see where culverts and storm drains are and fire hydrants. You can even see the quality of the road and the pavement on the road, or I'm sorry, the markings on the road. Because our imagery is used in a lot of 911 centers, you can use that in call taking and dispatch scenarios where you can understand the layout of a property. If you had a messy backyard like this one, there's lots of hiding spots where people could go. Where could they escape? What are the exit points in the backyard? All of this is valuable information for both first responders and the people on the phone. And here's just another example here of high resolution imagery looking at the roof load when you're approaching a building where if there was a fire, you had to access it from a roof or something like that. So that's it for me on this part. I'm going to go ahead and hand it over to Ruth Zipfel, who again is our district sales manager out in California. And she's going to talk a little bit about Hawaii and the imagery projects that we have going on over there. So Ruth?
Awesome. Thanks, Joe. I appreciate it. Good afternoon, good morning, everyone, depending on where you're dialing in from. I'm going to be really brief because I do want to pass this on to Akimeka so they can get more into the nitty-gritty of what it is that they do in conjunction with us across the state of Hawaii. So as Joe mentioned, I'm based in Sacramento, California, but I do manage the state of Hawaii, and I've been working with our customers out there and with Akimeka for about the last 6 years. And can we go to the next slide here, or I guess I have a little bit of control here. So in Hawaii, we have been flying with the state through the E911 folks since 2008, and our refresh is about every 2 years. We have four aircrafts that are permanently stationed on Hawaii, and because of the climate, we have a lot of challenges with the cloud deck and storms and the terrain in general, so it takes us a little bit longer generally to capture across the state of Hawaii than it does in some of our mainland counties and states. But the main folks using it out there, as I mentioned, are public safety, but as many of you who are customers of ours know, when a county comes on board with us, it umbrellas every agency within the county. So assessment uses it, GIS, planning, public works, you name it. They're all able to utilize it and share this imagery out. But as we have been working a lot more in the public safety realm and moving towards the standardization, 911 standardization, NENA standardization, as many of you know, across the country, it's become more and more pertinent. So I'm really excited to be here today to share with you what it is that we do with Akimeka, because I feel like they are an exemplary example of where people are headed that are trying to get their GIS data aligned with imagery and aligned to fit into the dispatch centers and with public safety officials overall. So we have been partnering with Akimeka for many years out there. They support, as we're going to be talking about a little bit more, the public safety and the PSAPs throughout the state. This creates heightened situational awareness for not only the public safety officials, but also for the public in response times, and making sure that we are able to get to where we need to be in a very timely and efficient manner. So we fly the entire state of Hawaii. I have a map that I threw up here for those of you who may not be geographically familiar with the state. There are 4 counties: Hawaii County, Maui County, Honolulu County, and then Kauai County as well. Sergeant Pereira was supposed to be on our call today, but unfortunately she got called out. She's getting promoted to lieutenant this week, and they had a mayor's inauguration today, and so apologizes for not being here, but we'll do our best to kind of cover and fill in the holes for what she was going to be talking about today. So we do fly the entire state of Hawaii, except for the very far northwestern island that you see. That's Niihau, and it has been privately owned for 150 years. That's in order to protect their language, the heritage, and the traditional Hawaiian culture there, so they don't open that island to visitors, and therefore we don't actually capture imagery out there, but we do fully fly the rest of the county. So I'm going to hand the state, and I'm going to hand this over now to Katya, who's going to do a little bit more of a deep dive into why you're here today, how NG911 data can be used in compilation with imagery and get you to where those standards are kind of taking us from a nationwide perspective. So Katya?
Thank you, Ruth. Let me advance the slide. Okay. You guys hear me okay? All right, awesome.
We can hear you.
Yeah. Thank you, everyone, for joining. My name is Katya. I'm a GIS manager here in beautiful Maui, Hawaii. I see a lot of folks that I recognize on the attendee list. I used to be with Imagery out in Redlands, California for about 15 years. So very glad to see familiar names, if not faces. So today I would like to talk about Akimeka's 911 program and how we use imagery from EagleView, how we use it, and how 911 centers use it here in Hawaii to improve the response time. So before I get started, a couple of definitions. I see we have folks from 911, from emergency services, and we have some GIS folks. And there are some terms that mean slightly different things for GIS than they do for 911. or may not be familiar. So for example, when we talk about a PSAP, PSAP is a public safety answering point or a 911 dispatch center. MSAG is something we're gonna talk about a bit when we talk about synchronizing different databases, and it stands for Master Street Address Guide, and that is basically a table of valid street ranges within a jurisdiction, and that is what a telephone company uses to check validity of an address when you get a new service. So when you get a new landline, they need to put in the address of the service and make sure that fits into the ranges of the Master Street Address Guide. And so we make sure that our GIS and our MSAG here in Hawaii are synchronized. ALI is another term you might hear today. It stands for Automatic Location Information or Automatic Location Identification. And that is information that comes along with a call. So if it's a landline call, it's usually an address. And if it is a wireless call, and the majority of calls these days, of course, are wireless, then it may be an XY or the name of the sector or wireless tower that picked up the call that is transmitted. And then that needs to be translated into an address or an XY that the system understands in order to get mapped. And then CAD is one of those things that means different things to PSAPs and to GIS folks. So when we talk about CAD today, we're talking about computer-aided dispatch, not computer-aided design software. And then finally, the response time. When you make a 911 call and you need help, you would probably use one definition, but the responders would use a different definition. And it's important to understand that. So for you making 911 call, the response time is from the time you dialed 911 to the time the responders show up. But the responders aren't dispatched immediately. The call taker needs to figure out where you are, and then needs to figure out what equipment to send, who is first in, and all of that takes time. And that is something that we work to decrease that time. So to improve the response time with GIS, and Imagery is super helpful with that. So let me start talking about dispatchable location and data synchronization here that we do in Hawaii. And so first of all, location of an emergency isn't always an address. Especially in Hawaii, there's a lot of rescues that are happening out in the ocean and hikers in the mountains. Of course, there are car accidents as well. And so the emergency could be a residence, or it could be a location that doesn't have an address attached to it, but a location always has an XY. So what is a dispatchable location? So the dispatchable location is a location you can actually send help to, and it can get very, very detailed. So here's an example of an ALI record. So that is something that's going to get sent with a 911 call from a landline or a VoIP telephone. And this is a phone number here in the office on Maui. You can see the customer name is Akimeka. This is something Hawaiian Tel maintains. And then there's the house number, the street name, the community or a city. And then you can get very detailed. What is the location within the building? So it's Akimeka building, floor 3, suite 301, room 1, seat 2. You can get that detailed about the phone that is located at the address of 500 Aloha Street. And that information is sent to dispatchers. Additionally, you can see on the bottom of the screen, there are some other other values, and ESN is one of them, and that is Emergency Service Number. 315 in this case, which stands for a sort of geographic intersection of responding agencies. So a unique police, fire, and EMS response is going to form an ESN. So for us GIS folks, it's very easy to figure out by clicking on a map what police district or beat an area falls into, what fire district it falls into, what medic response area it falls into. But if you have tabular database, you need to specify that. And in MSAG and ALI, it is specified using this ESN, which again is a unique combination of those three responding agencies. So if a particular area has the same police and fire, but medic is different from an area across the street, then it's going to have a different ASN. So what we provide to our PSAPs here is a 911 address database. At first look, it's similar to just an address database that could be used by a planning department or public works department or USPS. But it is designed, one, to store dispatchable locations, and it is designed to, we really don't care about mailing addresses or equipment locations unless we're going to send a responder there. And it's designed to make the dispatcher's job easier. And it does that in a couple of different ways. For instance, the location names are agreed upon abbreviations. So every one of our police departments has a way that they like to refer to, say, 7-Eleven or any variety of other chains, so that a dispatcher can start typing in the name and it's going to show up. There are character limitations in the alley, so we can't always type in the whole thing the whole name, and we'll see that. So we have these abbreviations that the dispatchers know and the data reflects. We also have street segments, for those of you who are GIS folks, that are split at every intersection that creates those CSNs. So when the police beat changes or the medic response area changes and so on, we split the street segment. So every street segment that we have falls into one and only one police district and beat response area for fire and EMS. And that makes it easier for CAD to figure out which unit to send, which jurisdiction it's in, when it is close to the border and we're using street level geocoding. We also have a lot of multi-tenant buildings, and we include street records because there may be an incident that's not tied to apartment 1 or apartment 101. And so we would just have an address for the condo complex, say, itself, as well as individual addresses for buildings, so that you can tie CAD records to those things. Here in Hawaii, we have street names that have Hawaiian names, of course. And a lot of the time, one, they're long, and I mentioned character limitations, and two, they have okinas and kahakos. So here on the screenshot, I don't know how well you can see, there's Alanui ke Ali'i, and you can see okinas in there. Well, we have to remove those for ALI and MSAG because they don't support that. There are also dashes in some of the addresses. Those have to be removed and replaced with something that the system supports, but in a manner such that we can continue having street ranges flow appropriately. And I wanted to show you an example of this kind of translation. So the MSAG that's used here in Hawaii has the house number limitation of 6 digits, and they have to be numbers, no dashes. And as I mentioned, some addresses have dashes in them. And then street name has a length limitation, and again, no special character. So Alanui ke Ali'i that we just saw has to be converted to a name that the system supports. So here's an example of Kamehameha Highway, a very long name that we in MSAG convert to Cam Highway. And the street number, the house number, has a dash in it. So what we do when that number with a dash is less than 6 characters is we convert that dash to 0 to keep the blocks flowing correctly. If converting the dash to 0 makes it 7 characters, then we drop the dash. So in this case, 1-923 Kamehameha Highway becomes 10923 Cam Highway. And if we have that kind of address in GIS and we have that kind of address in MSAG and ALI, then we'll be able to, 1, verify the address, and 2, if a call comes in from that address, it'll be able to zoom in. But take a look at the table here for Cam Highway on the left-hand side of the screen. That range is not included. And so in this example, an investigation needs to happen as to why there is an MSAG address that does not fit into the ranges. And in this case, there's a mistake and it needs to be 1-123 Cam Highway in this example, which would fit into the range, instead of 1-923. And so once we figure that out, the address gets converted to an appropriate address. Now we're good to go. A phone call, a 911 call from this address would be mapped to an address point in the database. And that's what synchronization does. So here we have the alley stream, which has a lot of information in it, but one of the bits of information is the address, and that address is in the MSAG format. GIS has both the civic format, so that's 1-123 Kamehameha Highway in this case, and the alley format. So that synchronization ensures that we know that 10-123 Cam Highway is the same thing as 1-123 Kamehameha Highway, and we can show the call taker where the call is coming from, if it is a landline call or a VoIP call, which is when the MSAG ranges are used. So NINA is the agency that sets standards for 911, and it recommends a minimum exact match rate of 98% between GIS and MSAG. And here in Hawaii, we are hovering around 100% for all counties for the whole state of Hawaii. And you can see specific numbers from the latest synchronization report that we did. The numbers that are 100% this month, for example, for Hawaii County, it's 100% GIS to MSAG match rate. Last time we did it. It might drop if there is a new MSAG record that comes in that wasn't properly synchronized, or a VoIP record that comes in. The one that's 99.78 for Honolulu, we'll probably fix that already, and it's 100% now. So next time it might show 100%. But the point is, those are both live databases. Also, this is for the whole state of Hawaii. And granted, the state of Hawaii is not a very big state compared to California or New York. But actually, it's not that small in terms of population either. Here is a list of the top 10 smallest states in the United States, and Hawaii is not in there. Well, actually, it's number 11. But it is not as small as you might think. There are actually quite a few people that live in Hawaii. And in addition, we have millions and millions of visitors, tourists that come here. So how do we use imagery to make sure we not only have GIS synchronized, but also that address point, that 1-123 Cam Highway, actually shows on top of the proper house, on the correct house? This is great to have everything synchronized, but if it's showing everything in the middle of the island because it doesn't quite know where it is other than that it's in Maui, it's not super helpful. Synchronization is going to be 100%, but not useful. So here are a couple of examples of where imagery is crucial to fix the GIS. So here we have caller location, the little cell phone in the middle. And a caller is calling from what looks like the left side of the street as you are going across. But if we bring the imagery in, you can see the red line, that's the GPS location. We actually drove a number of roads and fixed the GPS location. You can see that the caller is actually on the right-hand side of the street. And many times it's not important. You're still within a couple hundred feet of the caller. So if you make it to where the location is shown on the map, okay, fine, you'll find them. But sometimes you may not be able to. If it's at night, if they are unable to speak, if they're hiding, if it's a child, a number of scenarios where you need to know at least what side of the street they're on, or better yet, a precise location. And so this is the corrected example. And in this case, with this data set, it wasn't simply a datum transformation issue where everything is uniformly shifted a few hundred feet. This was actually differences in how the data was digitized as opposed to imagery. Now, this imagery from Eagle View is properly georeferenced to where it is on the ground. And that's important because the wireless calls come in WGS 84 coordinate system and get mapped in that coordinate system. So if you're using different projection or different coordinate system in your CAD, you need to make sure the transformation is correct. So in this case, this was one of the many corrections that we had to make. So here's another example where the address points are all over the place and showing on the wrong side of the street on the left without the imagery. You can't tell that they're in the wrong location. When you put pictometry underneath or Eagle View imagery underneath, you can see that everything is shifted. We fix the shift and then we move the points to where they are on top of buildings in this situation. And again, if you make it to this cul-de-sac, you should be able to find a house that the call is being made from, right? Well, not if they're not properly marked, not if it's at night. And one of the one of the ways that CAD maps and CAD imagery is useful is that it gives you the daylight view when you may be responding at night. Another example of where 2nd Street right here is going right through the middle of the building, and that can be problematic when you're trying to snap the location of a responding unit to the road in order to route them appropriately for things like AVL. So AVL systems benefit from detailed road network, and in this example we have before and after. The red before has inaccurate roads that are also not very detailed. We have a lot of parking lots mapped, and you'll see how that can be helpful in getting the responding unit to the right area safely and decreasing response time. Here, I think it's probably the last example that I have here with imagery before and after. And this is, we have very few points on the before, and then we have every single structure mapped after, as well as the roads. And that's important because if you have an address that is not in CAD, so the person gives you an address, you type it in and it's not there, you maybe go to Google Maps and it's still not there because it's a new development, then it's a landline call, you have no idea where they might be within the island, or sometimes even which island they're on. So mapping the actual rooftops is super helpful for that. Now I want to switch gears a little bit and talk about wireless calls. As I mentioned, the majority of calls are wireless calls. So you're not going to get an address there, hopefully. We'll talk about why I say hopefully. There, you're going to get an XY. Or sometimes you will just get a phase 1 call that's going to tell you which tower or which sector picked up the call. And so we refer to wireless calls as phase 1 or phase 2. Phase 1 are the calls where we don't have the location of the calling device. And phase 2 is when we do. That location may be very precise or not very precise. And we're given the confidence interval of that if there is a location. Here in Hawaii, we map the theoretical coverage area of every wireless sector. And so when a sector transmits a call and it's a phase 1 call, you're not going to see the XY of the caller. That's not part of the alley stream. You won't see the XY of a tower either, because unless the tower is on fire, we don't want to send the responders to the tower. What you will see is the theoretical coverage. And here's where it can come in handy. Of course, with things like rescues out in the mountains where the reception is not very good, but it's useful to see approximately where the caller might be located when we cannot get the XY because there's not enough of a reception. But also in town. So here's an example. It's not necessarily where the 7-Elevens are located, but here we have somebody calling about the 7-Elevens. It's a little bit hard to see on the screen, but we have 4 7-Elevens and in this area, and 2 of them are on Main Street, on the main drag right here. And so the caller is calling saying, hey, I'm at 7-Eleven, the baby's not breathing. And if we don't get the XY, well, the first question is, which 7-Eleven are you at? Or what address are you at? How many of you know the addresses of 7-Elevens in your area? I mean, nobody does. You might know the street that you're on, and that might be helpful. And so here, though, there are two of them that are on the same street. And where I live in Kihei, in Maui, we have a lot of ABC stores, right? If you've been to Hawaii, there's ABC stores anywhere. So there might be an emergency at an ABC store on South Kihei Road. Well, there's two. Which one are you at, right? So if we have the theoretical coverage, then we can see that the tower that picked up the call, well, there is a 7-Eleven within the theoretical coverage. So chances are pretty good that that's the one that they're calling from. Now, the call taker is going to rebid the call and try to get the XY, and that is always better to have, but that is not always possible. So we have that in CADs also to show additional information to the dispatcher. Okay. So here's a little bit of a summary of an address versus a coordinate system. At the end of the day, we always need an XY in order to dispatch, in order to figure out where they're at, because GIS doesn't really care about addresses, right? That's sort of a more of a human readable format. In GIS, we need the XY so we can snap to the nearest street, so we can route the engine there, and so on. And it may be tempting to snap that XY, if we do have it on a wireless call, to the nearest point. But let me show you an example where computer precision doesn't mean the dispatchable location you're going to end up with, a particular address, is necessarily accurate. Here's a location in South Maui where I hang out a lot. And it's on South Kihei Road, and I labeled 4 complexes in here, and the ones that are oceanside, there's actually 2 more in the picture, but they're not labeled. I guess we're not going to be talking about responding to those. But Hale Kamaole and Kamaole Sands are vacation rental complexes, so short-term rentals. Keonikaya Villages and Kihei Shores are long-term rentals and condos, so long-time residents live in there. So I went out to this location that's marked with a purple arrow in Keonikaya Villages, behind one of the buildings, and made a call from there. And so the call comes in with a particular radius, right? Confidence interval. And it was pretty good. It was like 50 meters, I think, which is very close. Like if you are within 50 meters of an emergency, most of the time you're going to find it. You're going to see it. So here's a picture of me. You can see there's a fence behind me. That's the fence between Kamaole Sands and Keonikaya Villages. You can see the red roof of a building behind the fence. That's Kamaole Sands. But the device is located right there where the arrow is. But it could show up anywhere within this 50-meter radius, which is 100-meter diameter. Actually, I think it's 50-meter diameter, so it's 25-meter radius, so it's even smaller. Could show up anywhere in this area. And it's tempting when you see the location of a device and a circle around it to think that, hey, this is where the device is. It's in the middle of a circle. But it could be in any one of these locations, which would put it in Kamaole Sands. Can be anywhere in these other locations, which would put it in Hale Kamaole or Kihei Shores, but actually I was in Keonikaya Villages. Why does that matter? Well, these complexes, you can't walk from one to the other. There's fences in between them, and you can't drive. So if there was a baby that wasn't breathing, or domestic violence in progress, or something that required really fast response, and CAD mapped it to the nearest point of where the location showed up, it could map it to Hale Kamaole. And this is the entrance to Hale Kamaole, the red arrow off of South Kihei Road. Kihei Shores driveway is right next to it, but it just goes past Hale Kamaole into Kihei Shores. Then Kamaole Sands is a really big complex right in front of Keonikaya Villages, and there are 3 entrances there. So the engine could approach through any one of those directions, get to me. I would wave at it and tell them to go around because they went to the wrong complex. And if I'm new to the area, if I'm just visiting, I don't know I'm in Keonikaya Villages or Kamaole Sands, Hale Kamaole, and so on. I might not even be able to pronounce those names. But I will be able to tell the dispatcher whether the house I'm at has red roof or brown roof or gray roof, and they'll be able to see that on the imagery. So that's one thing how imagery helps. But another thing I wanted to point out is that there is sometimes a push to snap to the nearest point. But as you can see, there's lots of points in here. Every single unit is mapped on our maps. And the one that is nearest to where I'm standing may not be the one that's nearest to where I'm shown as standing within 50 meters or 25 meters of my location. And that can really decrease the response time on a call where it matters. So here's the actual access to Keonikaya villages, which is from the top, and the fire station is south of this picture, but South Kihei Road, as you can see, is a busy oceanfront road, and there's a lot of people crossing it back and forth to go to one of these vacation rental complexes. So the engine might actually approach from the top if they're going to Keonikaya villages, and they know they're going to Keonikaya villages. And then this is what it looks like without imagery. It's very difficult to tell where the roads are, where the driveways are, which complex is which, even if it were labeled. So imagery is helpful when we correct the GIS data, and it's super helpful for dispatchers, especially at night, to see where they're going. So now I want to switch gears and talk a little bit about routing. And here in Hawaii, several of our police departments route based on location and first in using GIS. So before we talk about routing, I want to mention street level and rooftop geocoding. So again, for GIS, an address is not something that it cares about. An address is not an XY. We need to convert that address to the XY. So if an address comes in, either through the alley stream or the person gives the address of the emergency, which may or may not be where they're calling from. Oftentimes, especially elderly folks, they don't call 911, they call their children, and their children then call 911 and say, hey, my mom has difficulty breathing or whatever it might be, and she's on a different island, right? And so you give the address, and they transfer the call, and they have to map the address, which is not where the caller's coming from. So they take an address, and they need to convert it to a location on the map. There are two ways to do that, and that process is called geocoding. You can do street level geocoding and rooftop geocoding. Most of the time, they're very close by. So street level is where that range on the street matters, and that's the house on the bottom right. That's the street range on Kamehameha Highway. But this pavilion itself, because of very large parcel area and all the baseball fields and things, is actually pretty far away from the street address. So if we can, we use a rooftop geocoding. Sometimes that's not possible, so we also have street level geocoding. Here's one example. This is Walmart. There's parking on top of the building here, where it matters as far as response time, whether we use rooftop or street geocoding. So the highlighted segment, the yellow segment here on the map, is where the address falls into. And so when you call in, this is the segment that's gonna show up. And that's pretty good. That's where the entrance is. Once they get to Walmart, you'll be able to find the entrance to the store. Now, if we use the street level the rooftop geocoding, it's a big building. So where do we put that point? And if we are particularly unlucky in where the point goes, the nearest street segment that we need to snap to in order to send responders to this address may be the houses to the north of this Walmart. So what do we do then? Well, what we have to do is we have to make sure that either one, the point is closest to the street segment we want to route on, or, because that's very difficult to do and points move from time to time, force the proper segment. Okay, so here's an example of actually something that was reported to us by Honolulu Fire Department. This bigger building right here is Foodland. Foodland is a chain of grocery stores here in Hawaii, and they were routed to the back of Foodland when there was a call at Foodland. Why? Because the address point snapped to the nearest segment, and that nearest segment was the back of the store. So they had to back out of there and go around to the front of the store, and they wasted a minute or two in their response. So how do we fix that? Well, GIS allows you to force routing to a particular segment. And that's, after this, we actually went through the whole databases for all the islands, and we added what is known as routing ID. And so in this case, we're forcing it to route to this private driveway. Again, we have most parking lots mapped in Hawaii. And now when it routes to that segment, it routes you to the front of the Foodland store instead of the back, so you can enter it. And that saves time when responding. Now, the problem with forcing a particular segment to be used for each address is that we're all human, we can make an error. But the error in this case, if you fat finger the ID of the wrong street, you'll have the correct location on the map. But the engine is going to be sent not to the front of Foodland versus the back of Foodland, but might get sent to the other side of the island because we're forcing the location of the street segment to be sent to. And so we have quality control checks to make sure that it works. So Fishbones is one thing that many of you are probably familiar. It is, as the name implies, a visual tool that checks the street level geocoding and rooftop geocoding to see that the street segments are properly split up. And then what we do here with routing ID is we do the routing ID check, or as we refer to it, the valve bones. So fish bones are on the screen. This is where the address point is connected to the location on the street center line where it gets geocoded using street level geocoding. And this is valve bones. So they call them that in order of one of the GIS analysts that we have here who did fat finger a street and sent the engines a couple of miles away. It was like he just transposed some numbers. So in this example, you can see that we're connecting the address point to the street segment that it is being forced on. So you can see in this particular instance, there's two entrances. There's a little bit of an overlap, so we can fix that. This looks a little bit better visually. Again, valve bones is a visual check. Here's an example of where it definitely looks wrong. You can visually see there's a problem. And once you create this data set, you can sort by the distance of the length of that line. And here's a little area that all got transposed. And I think this is actually the area that Val fat fingered. And all of this street, or all of these houses get routed to an off-ramp a couple of miles away. So if we zoom into the streets, you can see these are the address points, and all of these lines go way off into the side, but they should be connected to the street that is highlighted. So once we fix that, rerun the valve bones, you can see that if the engine finds its way to the street, it'll be very close to the address where they're being routed to. Another thing that matters is speed limits, right? So if you put the incorrect speed limit when routing is being done to figure out which engine is closer, which police car is closer, and the speed limit on the highway is 25 instead of 65, then the correct route from A to B may be the one that's highlighted, but it's going to show as a longer route, and the software will instead send them a different way, which on paper, on a computer, looks like it's faster, but actually it's going to take them a long time to get there. So we do also do sweeps of speed limits, and we have our fire departments go out and tell us if we don't know what the speed limit is, or for that matter, where a particular address is, to go and do a check for us. And so the result of that here in Hawaii, this is just one example. This is for Maui. In 2008, for high priority calls, the average response time, as far as CAD is concerned, not the person calling, right? So from the time that the responder was sent out to the time they arrived was 6 minutes and 23 seconds. 10 years later, it was 4 minutes and 9 seconds. So it's a reduction in average response time of 2 minutes and 14 seconds, which if you have a baby that's choking on a fry in McDonald's, it's 2 minutes and 14 seconds is a huge amount of time, whether you have a drowning in the resort pool or something like that. Now, Maui has a lot of rural areas, so if you got high priority call that is very far away, that can skew the average response time. So we have other stats where another police department in a much more urban area went from using beats to using AVL to figure out which unit to dispatch, and their response time dropped by 4 minutes in their test. So from today to today, it was 4 minutes difference. And again, if it is something that you are you have a real medical emergency like a heart attack or a child that's not breathing, think about it. Seconds matter. Here, the response time using GIS, using properly vetted data, is minutes faster. Okay, so I think that's about all the time that we have. And I think we have a little bit of time for questions, so I'm going to pass it on back to Joe. See if we have any questions. Joe?
Thank you. Katja, thank you very much for that. That was extremely insightful. It seems like imagery is valuable in not just the, helping with responding to calls, but also maintaining the, getting that data that you have and getting it next gen 911 ready. It seems like just a lot of different use cases there for it to be used at 911. So we do have we have some time. So if there is a questions panel, Q&A panel within the interface there. So if anyone does have any questions, please go ahead and type those in. And while we have all of our folks on the line from EagleView and from Akimeca, we'd be happy to answer those questions for you. We do have let's see. We have one question says, do wireless calls use dispatchable locations for wireless calls like ERN site?
Okay, yeah, so the question is, do wireless calls use dispatchable locations for wireless calls like an ERN site? Yeah, so with wireless calls, there are two types of sites. There's what we call macro sites, which is those towers that you see on the side of the freeway. And then there are more and more of these microsites that are being installed in shopping centers or really big mansions or hotels, where you can actually have an address as opposed to an XY, and even be very specific, like, okay, well, if the call gets picked up by this particular part of the mesh network, then it is by the hotel pool. So this is the address, but then, so we do display that. So we will display, instead of the tower name or sector name, we will display the address for ERN sites. And we will also display information such as, oh, it's the hotel bar, or it's the front lobby and things like that. So yes, we do that.
Okay. Great, thank you.
Thank you.
Also from Akimeca, we have Tommy Takashita. He used to be a PSAT manager, and he may say a few things about, having been on both sides of the value of imagery in 911. So, Tommy, if you wouldn't mind taking a minute and just kind of sharing some of your experiences.
Oh, sure. Like Katya said, having that image in dispatch, a day view, really helps when the most serious crimes or car accidents happen at night. So having that day view imagery and trying to get responders to a location, oftentimes it really helps the dispatchers, because they can see what's around the location where they have to go to. Like she also mentioned, being able to view a location, instead of just giving out an address, you can help by explaining to the responders, okay, there's going to be a big red building on here first, and then because if they're responding emergency, as fast as they can go, they don't have time to be looking at a map in their vehicles or anything, or even sometimes those map views on their laptops, because they have to be aware of the traffic and what they're going through. So having somebody just step by step describing where to go really helps the time of the response time. And like I said, when people call 911, they take it for granted that the 911 center knows where you're at. That's not true, So, and they take it for granted that someone's going to appear right next to them in a couple of seconds, because the time seems so long when you're waiting. So, having to improve dispatch response is very critical to the dispatchers. It also helps during this period of time to process the call. When the dispatcher answers the call, the time before they can dispatch a responder is called the processing time. So having imagery to help locate people decreases the processing time, which increases the time for them to send the call to the responders, and that helps a lot.
Right. Great. Well, that's some great insight, Tommy. Thank you very much. Well, I have a quick question for Katya. If the folks on the call are interested in, is Akimeca basically open for business for helping PSAPs and local 911 centers update their data to be more next-gen 911 compliant?
Yes, great question. Absolutely. So we have two offices. We have one in Hawaii and one in Florida. And between the two of us, we are definitely able, we have the staff to analyze the data set and see what level of help you would like. We can teach you how to do it if you have GIS folks on staff, or we can take over and do what we do here and actually maintain the data set for you and then load it into CADs like we do in some cases here. Yeah.
Great. We have one more question. We have time for one last question. Do your responders use or see the same GIS and imagery in their 911 systems, and that being CAD, AVL, RMS, call recording systems?
Yes. So the question is, do the responders see the same GIS and imagery in their 911 systems? Yeah. So this GIS that I talked about is specifically designed for 911 systems. It's not designed or really used in other systems, though I suppose it could be. But as I mentioned, there are specifics on how we create street data sets and things like that, specifically to 911, and that is what they see, and that both in the CADs and RMS and all of the systems, and for finding an address and things like that. Yeah.
Excellent. And it is worth mentioning that for those of you not using imagery, especially oblique imagery in a 911 setting, EagleView does have partnerships with just about all of the 911 CAD providers that are out there. So if you're interested in seeing if your county already contracts with EagleView and getting that imagery inside your 911 center for that reason, we'd be happy to discuss those options with you. We are coming to about a close. I just wanted to let you know that if you do would like some more information from both EagleView, if you were interested in acquiring EagleView imagery or using it, in the ways that Katya described to help with your next-gen 911 data, or if you have data that you would like to avail the services of Akimeca to help to become more NG911 compliant, there is a button on your interface called Request Demo, and if you click that button, it'll reach out to us, and it'll take you to a web page where you can enter some contact information. It's got a little section at the bottom where you can type in some text about what exactly you're looking for. If it's an EagleView question, we'll route it to the appropriate salesperson within the country. If it's a question for Akimeka, we will relay all those contacts and feedback over to Akimeka as soon as the webinar is over. Lastly, this webinar was recorded, and all of you who did register, and even the ones who registered but were not able to make it, will be receiving an email about an hour after the call with a link to this recording so that you can watch it yourself again if you want to go back to a certain section, or feel free to share that with some of your colleagues if you felt that would be valuable for them, and they can watch this webinar at their leisure. So on behalf of myself, Ruth, and Katja, and Tommy, and everyone else at Akimeka, thank you very, very much for your time and your expertise. It was a very interesting talk. I hope the folks on the call found this valuable. And again, if you have any questions, please click that button, request demo, to enter your information. We'd be happy to get in touch with you. So thank you very, very much for your time today, and have a wonderful afternoon. Take care.
Thank you.